Okay, grab the door. I'm gonna start here. Systems. I know, it's sweet. Hey. Yeah. Oh, sweet. Yeah. Yeah. Much appreciated. Yeah, right in front of the door there. Right in front of the door. Yeah. Okay, so systems of equations. We're gonna do linear and non-linear. See, my black is messed up. Something's going on with it. So here we go with blue. Linear and non-linear. What did we did a couple things. We did these by algebraic method, right? When we had a linear and a non-linear. Somewhere there. Oh, right under the green binder there. We did substitution. And substitution. 3, we did that elimination method, or addition subtraction. Right? I think everybody found this fairly easy, and we ended up graphing at the very end. I guess this algebraic takes these two into account, and then graphing, because we did graph the linear stuff, and we graphed the nonlinear in the end too when we did the inequalities, and that's where we kind of messed around with that conic stuff, or what we called the conic stuff, whatever. So let's do some examples. Anybody got some examples that we can do? Out? Hey? Do we have any? Anybody got an example? You got your old tests out? Why? Where is it? Oh, terrible. Well, then I'll make one up. No, we'll just do a linear versus non-linear. Let's do that one. Okay. So how do I know which one's linear and which one's non-linear? Yeah, the linear one doesn't have any exponents. That's how we know. As long as we have an exponent, it's not a linear equation at all. When we do linear versus non-linear, what method do we like to use? Does anybody remember? Yeah, substitution. So I'm going to isolate a variable up here in the first equation, and I'm going to substitute it back into this one. So I'm going to isolate, obviously, y up here, because it's already ready to go. So y is going to equal negative 2x plus 4. And then I'll take this and substitute it in for y. Anybody recognize what kind of graph the second equation would be? Yeah, parabola, that's right. So I'm going to rewrite that second equation. 2x squared minus x plus 3 is equal to negative 2x plus 4. And now we can bring everything over and factor if we can factor. And if we can't factor, what are we going to try and use? Quadratic formula, yeah. So I'll bring, add the 2x over and minus the 4 over. Because that'll cancel away there and there. And I'll get 2x squared plus x minus 1 is equal to 0. looks like a trinomial difficult. Am I even going to bother, or should we just do quadratic formula? Yeah, let's do quadratic formula. Alright, so let's go right here. X will equal -1, because of the b here, plus or minus the square root of b squared is 1, minus 4 times 2 times 1, that's 8, so plus 8, because negative and a negative make a positive, divided by 2 times a, which is 2 times 2 is 4. So x is going to equal -1 plus or minus the square root of 9 is 3 divided by 4. So this one works out pretty nice, actually. So we could have factored this one. It would have worked out okay. So our x values for our solution are going to be x equals -4 divided by 4 is -1. And x is going to equal -1 plus 3 is 2 over 4, so 1/2. So there's our x values. Pretty easy. What do we do with those to find the y value now? Which one? Yeah, and does it matter though, Becca? No, you can plug it into whatever you want. Go into linear. We've already kind of isolated it here, so why don't we just plug it right into there? We'll just do it in our heads here. -1 in here. We got -2 times a -1 is +2. Plus 4 is 6. So our solution is going to be -1, 6 for that one. And we'll do the same thing with a half. We'll just plug it in. -2 times a half, the 2's cancel, so I'm left with -1. -1 plus 4 is 3. So our solution here is a half and 3. So there we go. There's our answers. So if we were to graph them without graphing, we know already that that's where they would meet. The two graphs would cross or intersect at those points. Good enough?